Hello and welcome to today's class. We're going to the concept of electric field in physics. So let's discuss the concept behind electric field in physics. And we'll look at its mathematical representation and other concepts. And also with all these concepts, we'll look at several past questions for JAM and WAEC and also for external students based on electric field. So what's electric field by definition? Electric field is simply a region in space where a body or object experiences an electric force. Alright, that's how you define electric field. Let's look at one key important concept called electric field intensity. Let's look at electric field um, intensity. Alright. Having explained electric field, let's look at the concept of electric field intensity. Electric field intensity is also called the strength of electric field, right? And it is simply the ratio of force to the charge. So I'm saying that electric field intensity is also called the strength of electric field. And by definition, it's simply the ratio of force to charge, right? So it's abbreviated by a symbol E. So electric intensity is represented by a symbol E. So E stands for electric field intensity in physics. So mathematically, I'm saying that electric field intensity, that is E, is equal to the ratio of force to charge. All right, charge. So note that E stands for electric field intensity and the same ratio of what? Force to charge, right? So by abbreviation, I can say that E is equal to force is of course F, charge is of course Q, right? Let's get the SI unit for electric field intensity. So from this expression here, we just said earlier that we just emphasize that this E, capital E, which signifies electric field intensity, is equal to force, that's F, all over charge, that's Q. From this concept here, we know that force is measured in Newton and charge is measured in coulombs, right? So from here, I can say that force, of course, in Newton, charge, of course, in coulomb. So I can say that the SI unit of electrical intensity is given by Newton per coulomb. So Newton per coulomb is simply the SI unit for the concept behind electric field intensity. All right, this becomes your SI unit. Also, on further coordination there, on further concept, I can still express the unit as volt per meter. I'll show you how we arrive at volt per meter, which signifies the SI unit for electric field intensity as we proceed higher, right? But basically, I have meter per coulomb as the SI unit, or you call it volt per meter as the SI unit for electric field intensity.
Alright guys, you can now join my channel membership to have access to exclusive videos of mine which most people will not have access to. To get this link, membership program, as you can see the left hand side of the screen, you can see the WAEC/JAM classes. You can go there. It of course 1,000 naira, or you go for the 100 level student to have access to both, right? So once you join the channel membership for other level student, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner.
And this concept here, let's proceed please. So put down please, given a charge Q and Q naught, given a charge q and q naught, given a charge q and q naught, separated by distance apart r, given a charge q and q naught, so q and q naught, given a charge q and q naught, separated by a distance apart r, as in this case, from Coulomb's law, F is equal to k q naught all over r squared. Right, from Coulomb's law, F equal to q naught all over r squared. So this becomes the format of Coulomb's law when it comes to electric field intensity. What do we know initially? Coulomb's law neutrally is F equal to k q1 q2 all over r squared. So in form of electric intensity, I have just Q and capital Q and Q naught. Observe the difference between the original Coulomb's law and the electric field intensity Coulomb's law. All right, let's proceed, please. From this concept now, from here, I haven't said this, please. From here, what's next? Observe that at this junction here, observe that I have my expression in this form, but we know something, exactly, but we know that this k has a value which is 1 over 4 pi e naught. So note that k is a constant and the value of the constant is 1 over 4 pi e naught as the value of k from here. All right, before I recall k equal to 1 over 4 pi e naught, let's spend this one first. Although k, this is the value for k, but let's spend this one first. I'll show you one derivation. So at this junction here, let me erase this. So, but we just established that capital E is equal to what? F over q. All right. So I can say express capital E, which is our focus is to get more formulas for calculating electrical intensity. The first one is force over Q. We're about to derive the second formula that can be used to solve electric field intensity. So I'm saying that, but you said E equal to F over Q from here. So anywhere I see F, I'll put everything here. So I'll have that E, that is E, observe E is equal to F. F is what? Everything here. That's Q naught all over R squared as the value here. That's for F. Divided by, I have Q. So I have Q. All right, I have Q here. Next task here, electrical intensity E is equal to K Q naught all over R squared times, of course, I will invert. That becomes 1 over Q. Please, Q naught and Q are literally the same thing, right? So this one here will cancel this one here. I'll have that the formula for electric intensity is equal to KQ all over R squared. So it becomes another formula for calculating electric field intensity, which is in form of KQ all over R squared. So I've gotten this expression. All right, at this junction here, I'll try to proceed further.
Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, WAEC/JAM student, WAEC/JAM classes for JAM students, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen.
By getting other expressions, but from here, we know very well that this K is called constant and the value is given by 1 all over 4 pi E naught. And we said this E naught signifies permittivity of free space. That's the meaning of E naught. Permittivity of free space. If this is true, I will insert the value of k into this expression. What do I get? Inserting the value of k into this expression, what do you get? All right. Putting k, so I have that electric field intensity, that is E is equal to, I have k. K is, oh now listen, I'll write this thing in this form. I'll have that k times q over r squared. This is still correct. K times q gives you kq all over r squared. So I know that this k exactly is this value here. So replace k as that value. So I have that E equal to k is of course 1 over 4 pi E naught. So I have 1 over 4 pi E naught. So I have becomes 1 all over 4 pi E naught times this one here gives you q all over r squared. All right, I have this place. Combine this, I can still express the value. I can still express electric intensity, that is E, to be equal to 1 times Q. That it gives you Q all over 4 pi E naught r squared. So this becomes the several mathematical expression for electric field intensity ranging from F over Q, and we have KQ over R squared, and also we have Q over 4 pi E naught R squared. It becomes several formulas for calculating electric field intensity. At this junction here, let's proceed by solving several past questions based on this concept. Let's solve some past questions based on electric field and electric field intensity. So I give you three formulas there. The first one there is F over Q. Second one there gives you KQ all over R squared. And finally I have Q all over 4 pi E naught R squared as expressed on the board. Let's use these three formulas to solve some problems and see how we can possibly solve problems involved in the study of electric field intensity and also electric field. Welcome back. Example 1 says, what is the electric field intensity at a point P 25 centimeter from a charge Q which is equal to 80 nanocoulomb? So it says, what is the electric field intensity at a point P which is given by 25 cm from a charge Q which is equal to 80 nanocoulomb? All right, when it comes to solving problem involved in electric field or electric field intensity or Coulomb's law, here's the concept there. You have to sketch out the diagram for that particular question. Here it says here that what is the electric field intensity? So I'm looking for capital E as usual. That says at a point P, right? Given 25 cm from a charge Q. So it means that I have my normal concept. So from charge Q, so this here becomes my Q, here becomes my P, right? So the distance from here to this point is of course 25 cm as indicated from the question. So I'm given a charge, um, I'm given a point P, this point P to be 25 cm from a charge Q, right? So I'm given that Q, so parameters please. Q is given as 80 nanocoulomb. I'm given distance, this is my distance R as 25 cm. What again there? That's all. So I'm given distance, I'm given Q. I'm have to find electric field intensity. That's E. So E is unknown. E is unknown. How do you get E? From here, please. First things first, I have to convert my cm to meters. Convert cm to meters. That gives you around divided by 100. I'll have 0.25 meters. That's the first task. Next task there is to get E. And what's E? First things first, E, we said E has several formulas there. But the best one I can use here is to use recall that we established earlier that E, capital E, equal to KQ all over R squared. All right. Capital E equal to KQ all over R squared. This becomes your formula for electric density. So I need two values. I need K is constant, and that's 9 times 10 to the power 9. Q is of course given, and R is given, right? So let's input values and again get answers for this place. So capital E, that's electric density, is equal to K is of course 9 times 10 to the power 9. That's for K into Q. What's Q? Q is 80. 80. Nano, please, N is nano and is what? 10 to the power minus 9. Please, N means nano. So nano coulomb, that's N. N means nano and the value of nano is what? 10 to the power 9. So that becomes 80 times 10 to the power 9 minus 9. That's for nano, right? So all over R squared gives you distance squared. That becomes 0.25 all squared. Let's get a value of numerator and divide it by denominator and let's get this. Capital E is equal to, if I divide into my calculator and let's proceed. Alright, let's get the answer to this place. This gives 9 times 10 to the power of 9. Alright, so divide, multiply by 80 times 10 to the power of minus 9. Alright, I have this place. So this gives me 720. This gives 720 for numerator all over 0.25 squared, 0.25 all squared. This gives around, this gives 0.0625. Let's get E. So E is equal to, divided to 720 divided by 0.6, 0625. This gives around, this gives 11520. Please, what will be my SI unit here? We said the SI unit of electric intensity is what? Newton per coulomb. So that becomes Newton per coulomb. All right, it becomes the value to the question given. So the electrical intensity here is given as 11520 Newton per coulomb. Let's solve on that problem and see how the second example goes. It becomes example 1. Example 1. So let's do example 2, please. So example 2. Example 2. All right. Example 2 says two charges 4 microcoulomb and negative 6.7 microcoulomb are separated by distance of 7 cm, comma, what is the electric field intensity, perhaps electric field at a point P which is 2 cm from the 4 microcoulomb charge? All right, let's get this question done, please. Let's get this question done, please. It says two charges, 4 microcoulomb and minus 6.7 microcoulomb. So we said first is first, try to sketch out your diagram, right? Very important place. So sketching a diagram, I'll have something of this nature. So it says this point here and this point here gives me this one gives 4 microcoulomb and minus 6.7 microcoulomb. All right. Next up there are separated by distance of 7 cm. So distance of separation between the two is 7 cm. All right. 7 cm becomes distance of separation. Next task, it says what is the electric field at a point P? So let's call a point P. Let's call a point here. Let's call somewhere here P, point P. All right, at the point P, which is 2 centimeter from 4 microcoulomb charge. So distance from this 4 microcoulomb charge to this point is what? 2 cm. All right. Please, if this point to this point 2 cm, what will be left here? It's easy as 7 minus 2, that gives you 4. So that gives you 5 per se. So here becomes 5 cm automatically, right? So it says that what is the electric field at a point P, which is 2 centimeter from the charge, from the 4 microcoulomb charge, right? So I have this concept here. So I'm asked to find the electric field intensity at a point P, at point P. So to find the electric field intensity at point P, it means that I'm going to compare point P with the first charge. The value I will add it up with the point P with the second charge. So I'm saying this, please. All right. First, convert your cm to meters. That's first task. That's the first case. Convert your cm to meters. So divide this one by 100. That becomes 0 point. So okay, let's see. 7 cm gives you divided by 100. I have 0.07 meters. Divide your 2 cm. I have 0.02 meters. Divide by 5 cm. I'll have 0.05 meters. All right. I've converted the values. Here is 7 cm. All right. Meter distance converted. So I have this stuff here. So here's the concept, please. Note this key point, please. Note this, please. Note the total electric field intensity at a point P will be equal to the total electric field intensity at point P will be equal to the sum of will be equal to the sum of the electric field at point P, the sum of the electric field at point P due to charge Q1 and the electric field intensity due to charge Q2. All right. All right. To find the electric field intensity at point P is more of saying I am focusing on point P due to charge Q1, point P due to charge Q2. So what I'm saying, like, so to get the net, so it's more like saying I'm trying to find the net electric field intensity, the net force. So I'm saying that capital E net is equal to perhaps E1 plus E2. This becomes electric field intensity at section 1, that is P to charge Q1 is this plus P to charge Q2. This is it here. So the net force, or perhaps the electric field intensity at point P, is E net, which is equal to E1 plus E2. So I can go and find E1 and find E2 at the same time. Let's get them one after the other. Let's get E1. So E1 here, E1 gives you, it's already KQ1 all over R1 squared. So represent them in terms of 1. It is the formula is given by KQ over R squared. But I'm having section 1 and 2 here. So this is my first charge Q1. This is my second charge Q2. Right? So in this case now becomes KQ1 over what? R1 squared. Guess values here. This gives K is of course a constant 9 times 10 to the power 9 as K into Q1 gives you 4 coulomb. So that becomes 4 times 10 to the power minus 6. That's for a micro all over R1 squared. R1 squared signifies your first distance, which is 2 centimeter. This is your R1, and the value is 0.02 meters. I have 0.02 meters. Of course, all squared. I have a square here. So the value for E1, that is the charge, that is the electric potential at point P due to charge Q1 will give me is now equal to, if I punch everything in full, 9 times 10 to the power 7 Newton per coulomb. All right. 9 times 10 to the power 7 Newton per coulomb as a value for the first E1. So everything here gives you this. Let's get the value for E2. Let's get E2. What will be E2? All right. That is the charge at point Q due to charge Q2. That's E2. Let's get E2. All right. From this point here, E2, that is the charge at point Q due to charge Q2, that's E2, will be equal to, in form of 2, that becomes KQ2 all over R square 2. This gives you, alright, this gives you K is of course 9 times 10 to the power of 9, that's K, into Q2, of course, my charge Q2 is negative 6.7 microcoulomb. That becomes negative 6.7 times 10 to the power minus 6 all over R square, R2. This is the second distance, R2. That is the distance from charge Q. The distance from point Q due to charge Q2 gives you 5 cm. And that's 0.05. That becomes 0.05 perhaps all squared. So the E2 gives you, if I punch calculator, E2 should give about negative 2.4, negative 24.12 Newton per coulomb. Alright, if I punch the value, times 10 to the power 6 times 10 to the power 6 times 10 to the power 6 Newton per coulomb. Alright, if I punch this value here, gives you this. If I punch the value here, gives you this. So let's get the total force. Let's get the force at, let's get the electric intensity at charge Q due to charge Q1 and charge Q2. Right, let's get that place. So I've gotten E1, I've gotten E2. Let's get the E net.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen.
Of the two charge space. So from here, let's get E net. All right, E net, from here, E net is equal to E1 plus E2. Of course, E1 gives you this one here. That's 9 times 10 to the power 7 plus E2 gives you negative 24.12 times 10 to the power 6. 10 to the power of 6. So the E net will be equal to, if I add these two, okay, from here I'll have 9 times 10 to the power 7 plus minus gives you minus 24.12 times 10 to the power of 6. So subtract this one together. The innet will be equal to, if I subtract the two values from here, I will have about 65.9 times 10 to the power 6 Newton per coulomb. Alright, this becomes your value for the charge at point Q, right, due to charge Q1 and charge Q2. This becomes your answer to that question. Although there's a kind of parameter that represents 10 to the power 6. 10 to the power 6 has a prefix. That's mega. So mega is 10 to the power 6. We have kilo, 10 to the power 3, mega 10 to the power 6, a giga 10 to the power 9, tera 10 to the power 12. So I can say that 10 to the power 6 is here, and the prefix is mega. So I can express my answer as 65.9 mega. Mega means 10 to the power 6, then Newton per coulomb is still perfectly correct. So you leave your answer in this form or in this form is still correct. This is a solved problem involved in the concept of electric field intensity. In the next class, we'll look at the concept of electric potential. All right, see you in our next class.
I just launched my website www.ghanabukari.com, as you can see in the screen. In this website, you can get close to 4 to 5 tutorial courses that are there. So we have different courses there. Also, the book I just launched also is in the website. You can visit our website and get the courses you want to watch. And also, the video you're watching recently, you can get more of these interesting videos in the website. So do well to visit the website and also register an account with my website. See you guys in the website, and make sure you buy a course from the website to support our journey of this academic platform. Thank you guys, and welcome to my channel.